All right, everybody, welcome to week 9 of Energy 241 alternative fuels, and this is the Thursday edition. And I want to go over the week 7 problem because everybody's been kind of having some issues with that, and I'll go over it because interpolation is kind of a big deal. Of you need to know how to do it, both visually and mathematically. So we'll take a look at it. Since everybody's already turned this in, I'll show you the version that I'll show you the solution that we have for this and kind of explain it as we go. To do this visually, if you read the problem, we're looking for a 35% load. And these lines up here represent 25%, 50%, 75%, and 100%. So 35 is not represented by one of those lines. So, and 90% doesn't. But what we're looking for, our fuel efficiency is over here on the y-axis, and pure propane, or the percentage concentration of propane, is on the x-axis. So what we're looking at is we want to find 90%, which is our level, as our propane density in our fuel, and we're looking for 35%. We know it's going to be somewhere here between 50 and 25, and a little bit closer to 25, obviously, rather than 50. So I can eyeball it, take a ruler, and say, you know, that looks pretty close to about 18% efficiency. You know, we can eyeball that, and we can get pretty close by kind of favoring the 25% line there versus the 50% line. You know, and that's great for just casual information. If I just need to know that just for, you know, just a random, if I don't need an exact number, just in conversation, I'm talking to somebody, I can say, hey, it's about 18%, that's close enough. But obviously, in science, we want to be more specific and we want to deal with that. So we have a formula to do that, and we'll kind of go right down the list here with this formula, and I will actually work it out on the bamboo pad so you guys can see it. What we're going to do is start out with our basic equation. This equation is going to give us the exact number rather than the roughly 18% that we eyeballed and said, yeah, that looks about right. So the formula is y equals y0, which in this case, y0 is 14%. We'll go back to that here in just a minute. Let me just write out the equation first. Plus x minus x0 times, I'm going to do some squiggly brackets here. You'll have to forgive me for, may not be the most. There's our bracket. Then we have our,
is that a summation bracket?
yeah, or one of those mathematical brackets,
Yeah,
whatever. I said it's not the most accurate representation, but
well, I was just wondering if it was a sigma or a closing bracket. A closing bracket.
x1 minus x0. So what this, by using this equation rather than eyeballing it, this is going to give us the exact numbers, because it's going to give us the difference of that 35% that is not represented. It's going to tell us what the difference is between the 25% and the 50% line. That's going to be this section right here. Basically everything in parentheses and brackets is just to figure out what is that representation of 35%, since we don't already have a line there. Then the y0, let me go back to the drawing. our y0 we determined on our 25% line was 14. So we know that it is larger than 14. So everything in that formula in the brackets is to tell us where exactly numerically that falls above 14%. So the way this equation reads out literally is that everything from here to here is just telling us how much above 14% efficiency. And this number right here is our 14%. Now what I ran into with helping folks in the office on this, very, very important that you put down a table and remember what each one of these numbers are, because we have a lot of numbers here represented and each one of them needs to be, you need to be able to keep track of. And if you don't have each one of them labeled, it can be kind of tough. So Y is what we're looking for, and that is our efficiency at 35% load. So we'll go right down the list and start labeling everything out that we need here. So we need to know what Y0 is. Y0, we go back to our drawing. Y0 is this line that we drew across where 25% load meets up with our 90% concentration of propane. You know, maybe not the perfect exact number. We're also kind of estimating on this a little bit, but we can use a ruler and say, yep, that's pretty close to 14. So we're going to use 14 as our value for Y0. So now we need to find Y1, which is also in that equation, and Y1 is where our 50% line intersects, and it looks like it's at right at 23%. Alright, our X value was given to us. That was the efficiency, or the load, sorry. That was the load that was given to us, is 35%, that's what we're running at. Next up would be X1, and these are the two lines that we're going between. X1 being the 50% that we're given, we have that line, and X0, which is the 25% line. Now that we've got all these numbers, all we have to do is plug them into the equation. Just that simply. So it's just going to be a Y equals, what's our Y0 value? 14% plus, now remember everything between these lines up here, that was our difference. So our 14%, that's our starting point. All our calculations up here are to figure out what's getting added to that 14%. So our X value is 35% minus X0, which is 25%. All of this is times our Y1, which is 23% minus our Y0 again, which is 14%, divided by our X1 value, which is 50%, minus our X0 value, which is 25%. So you have to remember our order of operations on this to figure it out. Everything in the brackets gets done first, right? So inside our brackets, This is going to be 9% divided by 25%. And come back, we're doing our stuff within the parentheses. That's going to be 10%. And we're going to keep this 14 out of there for right now. So we do the math on that, and this works out, or actually we can rewrite this. Let's do 14% plus. So it's going to be 14% plus 10% times 9% divided by 25%, or 14% plus, I'll take this all into one bracket. This works out to 10% times 0.36, 14% plus 3.6%, 17.6% is our answer by running it through the equation. So you can see we eyeballed it pretty close and said, yeah, that's about 18. When we look at the picture and use our ruler, that looks about right. But 17.6% efficiency is much more exact. So that's how you do it mathematically to make sure that you are giving the exact number. And like I said, in conversation, probably not necessary, but in real life, when we're dealing with scientific stuff, the other thing is, if I want to know what my efficiency is, and you're talking about something like a generator that runs 24 hours a day, 7 days a week, that's powering a building, powering, say, a hospital or something like that, that estimation of 18% is great, but that actual 0.4% of your efficiency level could equate to thousands of dollars or more at the end of the year of what your expected fuel economy is. So we do need those exact numbers. So that gives you a little better idea how to work that. It's actually not near as complicated as the equation looks when you first look at it. It's pretty simple stuff, but it's a lot easier, I know, if you see it and you actually see somebody do it and work the numbers. So I would say number one on this, list out all your variables with their values before you ever start on the equation, otherwise you'll get confused. Determine which ones are which by looking at the chart, and then just do the simple math, and it's actually pretty easy. If you have any more questions about it, feel free, come see me or Brad, and we'll be more than happy to help you out with it.